Hello बच्चों, let us read the question. A metal rod OA and mass and length R kept rotating with constant angular speed omega in a vertical plane about horizontal axis at the end O. The free end A is arranged to slide without friction along a fixed conducting circular ring in the same plane as that of rotation. A uniform and constant magnetic induction B is applied perpendicular and into the plane of rotation as shown in figure. An inductor L and external resistance R are connected through a switch S between the point O and point C on the ring to form an electric circuit. Neglect the resistance of the ring and the rod. Initially, the switch is open. Question A. What is the induced EMF across the terminals of the switch? Question B. The switch S is closed at time t equal to 0. 1. Obtain an expression for the current as a function of time. 2. In the steady state, obtain the time dependence of the torque required to maintain the constant angular speed, given that the rod OA was along the positive x-axis at t equal to 0. तो इस क्वेश्चन का कॉन्सेप्ट है इलेक्ट्रोमैग्नेटिक इंडक्शन. Electromagnetic induction. Magnetic induction when a current is produced due to an EMF which is called a changing magnetic field. इस क्वेश्चन को सॉल्व करने के लिए पहले जो डिटेल्स में दिए हैं उसको नोट करेंगे और हर एक सब पार्ट को आंसर करेंगे. So given length of the rod is r and the constant angular velocity is omega. तो इसको सॉल्व करने के लिए हम ये एक डायग्राम लेंगे. So let us say we have this. This is OA. Let's say at some distance from O, which is x, we consider a small element of length dx. और इसका velocity है ऐसे, because this is on a frictionless surface, so we can write the velocity of the element. So consider a small element of length dx. So the velocity of that small element is given as x omega. So therefore now we can see this small element में एक induced EMF है dE, which is given by BVL. So in this case, this is B. V is x into omega and L is dx. So small element के across induced EMF होगा B omega x dx. So integrate करेंगे. So integral dE is equal to B integral x dx और यहाँ length of the rod integral होगा. So therefore E of V B omega r divided by 2. So this is the EMF induced across the switch. Part B में they want to find out the expression for the current as a function of time. So you can say B. This was A. So at time t equal to 0, switch is closed. Switch close होगा. So यहाँ पे it is a case of current growth in an LR circuit. So current growth in an LR circuit. So that is given by, so the current at any instant of time in an LR circuit is given by I naught. So अगर वो current growth है, so this is 1 minus e to the power minus r by L into t. So E naught is the initial current. So we have I naught to be calculated as the induced EMF divided by the resistance. तो previous step से हमें induced EMF का expression मिला b omega r squared divided by 2, and अभी the current will be v omega r squared divided by 2r. So therefore I is equal to b omega r squared by 2r into 1 minus e to the power minus r by L into t. तो ये था फर्स्ट पार्ट ऑफ क्वेश्चन बी. अभी सेकेंड पार्ट के लिए, so they want us to write the net torque as a function of time. तो हम ये कह सकते हैं at constant angular speed net torque will be 0. So steady state current को हम ये लिख सकते हैं कि it is equal to I is equal to I naught, which we have seen to be equal to b omega r squared by 2r. So now we will take the right hand rule and draw one diagram. So from the right hand rule, so we can say this is the circle. So let us say question में ये दिए कि at t equal to 0 it is along the positive x direction. So at some t equal to t, तो ये इस position पे आ जाएगा. So we will call this B A. So this will make an angle theta. So theta is given as omega into t. तो अभी right hand rule से हम ये देखेंगे कि the current will be inwards and this will be the direction of omega. So this is I equal to I naught. So now we will draw the same diagram with the forces. तो ये है center. अभी the magnetic field is going into the page. So this is the rod which is making an angle theta. तो इसका center of mass होगा at r by 2. So this will be the direction of the magnetic force, and it will also experience the gravitational force, which is W. So ये gravitational force होगा mg cos theta, because this angle is theta, and this Fm, we will see how we will be able to write this torque of this system, complete system. So we will have the magnetic force. The magnetic force is given by Fm is equal to I into L into B. So in this case it will be IR into B. तो I का वैल्यू हमें मिला B ओमेगा B omega R squared by 2R. So into R into B. So the magnetic force comes out to be B squared omega R cube divided by 2R. Now we also have the torque due to the magnetic force. So the torque due to the magnetic force, वो हम tau m represent करेंगे. So that is equal to Fm into R by 2. So Fm का value हमें मिला B squared omega R cube divided by 2R into R by 2. So the torque due to the magnetic force comes out to be B squared omega R power 4 divided by 4R. अभी हम देखेंगे the torque due to the weight. So tau W will be mg cos theta into R by 2. तो अगर थीटा को हम ओमेगा टी लिखेंगे, so we will get the torque due to the weight to be mgr by 2 into cos omega t. So therefore the net torque will now be B squared omega R power 4 by 4R plus mgr by 2 cos omega t. So this is the expression which shows the dependence of the net torque on time. Hope you have understood it well. Best of luck.